Okay. Of all of the connectives that we've seen so far, in terms of importance, I'd say conditionals really rank up there as the most significant, part of this. Maybe that's my perception is skewed as a math teacher, but most of the stuff I've been doing through the years ends up relying on if-then type statements an awful lot. So I wanted to take a look at some possible variations of a given conditional statement. So we're going to look at a few of these in context. There are PowerPoint slides posted. Have them handy. The score at this stage. So a regular conditional statement looks like P implies Q. Relax for the moment. This is not a truth table. I'm just trying to keep things kind of sorted on the board without having to do an awkward erasing. I also want to look at this in the context of a specific example. So my example sentence here is, if it's raining, then I'll wear a coat. So if it's raining, then I'll wear a coat. I apologize for trying to squeeze the handwriting in there. But so we've got the standard if P then Q example. Hopefully that makes sense. So there are three main variations of the conditional that I want to focus on. So in terms of things you might try doing to a conditional statement, I think these are the might be kind of the natural operations. So on the one hand, we might flip-flop the position of P and Q in the arrangement here. That's what we call the converse of the original statement. So I'm going to abbreviate that in the interest of board space. So the converse of P implies Q symbolically would look like Q implies P. Now, in the context of our specific example here, that means the if stays in place. Don't move the if. Remember, keep the if intact. A lot of my students will end up trying to move the if around. Don't do that. Don't activate the trap card. So I will play around with verb tenses a bit here just to try to make the sentences flow more smoothly. It's if I'll wear a coat sounds weird. So if I'm wearing or if I wear a coat, then it's raining. That's one variant down. That's the converse. So on the other hand, maybe you would want to apply some negations to this guy right here. So we're not actually going to move anything around. We're just going to put a negation on both pieces of the conditional. If you do that, that's what we call the inverse. I'm abbreviating again. So it would look like not P implies not Q. So we got a twiddle on both sides, but P and Q are in the same place. So now, if we change this into our playing around with our example sentence, if it isn't raining, because we don't want to move that, we just need to negate it. So I've tossed in a not. If you said if it's not raining, also fine. Then I won't wear a coat. So that's our inverse. We've applied a negation in each instance. It's kind of hiding in the contractions, but English, what you're going to do. So now, lastly, we're going to do both of the things from above. We're going to flip the order of the terms inside our conditional, and we're going to apply negations. So that's going to look like not Q implies not P, and I won't abbreviate this one just to be clear. That's what we call the contrapositive of the original conditional statement. So again, if you need to write down the full words, they're in the slides. I'm word space. My hands are tied. So now, if I wanted to write out a sentence form, of the contrapositive of this fella I started with, if I'm not wearing a coat, okay, that's going to bug me. I tried to write cot, and I'm not sure many people will be wearing a cot regardless of the weather. So now if I'm not wearing a coat because I've needed to move this up front with the if and I've needed to apply negation, then it's not raining. Okay, so it's an example of how to mix these things up. Converse, inverse, contrapositive. Okay? That's the setup. Now, the important question, and as you may recall from where the last video wrapped up, is talking about equivalence of these variant conditional statements. So you may end up wondering, are they all different ways of saying the same thing? If they aren't, are there any relationships between them? So you can sort of suss this out on some level by trying to talk through this particular example. So does this really mean the same thing as this right here? So, I mean, for what it's worth, if you see somebody wearing a coat, does that automatically mean that we've got water falling from the sky? No, not really. I'm pretty sure we can all come up with other reasons why you might want to wear a coat. So same thing here. Again, if it isn't raining, then is that automatically a guarantee that you won't put on a coat? Yeah, it feels kind of awkward. So trying to figure out the relationship here just from looking at the words, you might get a sense that some things aren't quite lining up, but how do you nail it down for certain? That's where the truth table stuff comes in. So, ta-da! So yeah, I'm trying to make these jump cuts less painful for myself. Anywho, so I've gone ahead and set up a truth table here. So we've got our conventional PQ, true false setup. I've also taken the liberty of going ahead and copying in the format of that standard conditional statement from our truth table handout. So now let's see what we can investigate. So we have Q implies P. Now things are flipped. This is where that LR thing ends up coming in handy because that's my left-hand side and now P is my right. It may not change much yet because true implies true. That's still true. False implies true. That one's okay. That's where you have the super nice roommate who gets you a sandwich even with no money handed over. True implies false. Yeah, that's the one that's false. That's when you get mad at the roommate for taking your money without a sandwich. False implies false. Yeah, that one we said before is true. And you look at that. Are they equivalent? What's got to happen? They've got to be exactly the same. They're not. We got 2 out of 4, but 2 out of 4 is not 4 out of 4. So as such, the converse is not equivalent to the original statement. So that kind of jives with the intuitive, does that really going to work out thing that we saw previously. So the converse didn't work. What about the inverse? So now I technically need to scribble out some negations here. So again, I'm just going to flippity-flop the true-false values here. False, false, true, true. I do the same thing with my Q column. False, true, false, true. Then we have not P implies not Q. False implies false. That one is true. False implies true. Also true. True implies false. Survey says that's the one that's false. True implies true. It's true. So, still doesn't match the original. We can compare these guys. They're right next to each other. So the inverse is also not equivalent to the original conditional statement. But if you think back or rewind the video or whatever, this is exactly what we had when we came up with the converse. So the converse and the inverse are in fact equivalent to each other. But neither of them matches up with this guy. Okay, 2 down, 1 to go. Ugh, I feel dirty inside. Anyway, so the last one we need to investigate is the contrapositive. So we still need the negations of P and Q, so I just went ahead and left them up here. But now, when we work out that conditional, their order is flipped. So we have not Q implies not P. So now, Q's on the left. That's important. Here, I'm going to mark that because I just about screwed it up. So Q's on the left, not P is on the right. False implies false. That's true. True implies false. That's false. False implies true. It's true. And then true implies true. That one is true. So now, if we compare these 2 columns, lo and behold, they are in fact equivalent to each other because they match up exactly. So in terms of what we've ended up learning here, we get the following. I'm not going to jump cut this time. By God. All right. So the original statement is in fact equivalent to the contrapositive. So we got that. Contrapositive, original, they were equivalent to each other. That's what I just erased. The converse and the inverse are equivalent to each other. But not the original. So that's our setup. The original and the contrapositive are saying the same thing. The converse and the inverse are saying the same thing. But they're kind of two separate, there's no overlap there. They're two matched pairs. All right. So that's like 80% of what's in this section. I've got one last idea I want to talk about. We're going to come back to that one truth table that we haven't done anything with yet on that handout.